really interesting. Um, so this one this one is about a small ignition grant. At APL, we have started a program where we give money, where we choose some themes every quarter or every 6 months, like cybersecurity or various kind of health or various kind of schemes, and one of them usually is an innovative idea about whatever you want to do, and people vote on those schemes or those ideas, and 4 or 5 of those get $20,000 or some really peanuts money that you burn out in, like a team can easily burn out in 4 or 5 days. But some people want to do this on their own, and they put in their time, and they really do some good job here. So one of this idea was proposed by Nate Parsons. The people you see named there, these are all embedded engineers from my group, System Space Implementation Embedded Engineering Group. And what we did here is put CFE onto a UAV using ARM-based board. So I'm just going to quickly describe that project to you and whatever lessons learned or whatever goals we achieved. So the goals were to demonstrate that we can use our APL's core flight software that runs on top of CFE in a completely different domain. And we also ended up using something called as a very lightweight ground-based mission ops console or control software also as part of this, to pick up a very low-cost and extensible platform for figuring out if we need to mature anywhere our software, capture the process for rapid development, and design and execute within 10 weeks. That's what we wanted to achieve. The benefits were that we have provided a low-cost flight-like environment. I don't know whether or when we will get to use this, but it's a $40 board that can sit on my desk, and we can test out something really quickly if we need to. Also, if we had found any bugs, that would have been nice in a way, but I don't think we found bugs. But and build awareness of APL core among our wider group of engineers in APL, where space is just one department and there are a lot of other departments. And enhance this technology demonstration to sponsors for future. So they bought a Parrot AR drone. I don't know the exact cost, but I think this was less than $400 or $300. 200? Oh, yeah. Okay. Thank you. So it came with HD camera and 3-axis gyroscope, all those sensors and devices. And this one didn't have a GPS, but there was a recorder. You can get a GPS USB recorder for it. And you can also get that 60 frames per second camera for ground speed measurement was also there. And it comes with, I believe, the UDP commanding API and things like that. So the next one. In comparison to a spacecraft, this table shows you the capability of what it has, right? 66 megahertz spacecraft versus a 700 megahertz ARM processor. RAM is really high. We used Linux on this, but I bet Joel will have, or Joel's RTEMs could have been used also. But this had to be finished in 10 weeks, so they choose the lowest path there. And instead of that L3 ground system, we used a micro mock. That's what we call. It's a Python-based ultra lightweight basically with a GUI and a backend interface. That's about it. But the core flight software applications that ran, you can see they were all spacecraft based. So this is how it looked. It was assembled in a lab. APL has a lab where you can just, it's open 24 hours. They go in and whoever wants to go, they do whatever they want to do there. And that's where it was assembled with a Raspberry Pi and tried to stabilize the flight initially. In terms of the core flight software that ran on there, it's a collection of reusable CFE applications and libraries. We have actually, that particular collection is flying right now on RBSP or Van Allen probes, and it will fly on Solar Probe Plus without any change. Basically, just as it is, it will fly. And it has a heritage also from previous missions like Messenger, New Horizons, and Stereo. So we were pretty confident about that there won't be huge crashes or things like that. Okay, and it runs on multiple platforms. So ARM was the last one that got added in this. This is your typical CFE lollipop diagram. That's what we call those. And different apps are there. The first one is probably the most important, scheduler. Then there is command ingest, command manager, telemetry output. They added a drone control. So these are the new ones that got added. That's the only one that needed to be added. And there were other libraries, but they were not used. So in that drone interface, I believe two of the software engineers probably worked a couple of overnights to get this done. But it came together pretty well, and it reduced the way the drone interface was done as a CFE app. It reduced the network load for commanding data, and the integration went very quickly. And I guess I'll give you the. Let me show you the. I don't know if this is very visible, but the interface for the operator was such that you can see the pitch and the yaw and the altitude and the battery remaining on the drone, or the signal strength that it is reporting, and the very basic sensor data was being shown on the micro-mock. It's a graphical interface, but it's very rudimentary, and it serves a purpose of just proving a concept. When you're trying to bring up a simple interface or a simple device, a new device. The results are that real-time commanding is possible of a quadcopter, and available. We can probably do a rule macro-based commanding that we use heavily on a spacecraft. And this could be an easier way to test out some things that we don't anticipate, or during the design or during normal test plan building, we may not have anticipated. Relative and absolute time tag commanding was also proven. Some sort of telemetry recording and playback was proven. So it is ready to be used as a platform for future developments in flight software, and we'll see whether and how we can use it. Maybe I'll report that to you next year or year after that, if we really used it or not, but we'll see. That's all this presentation is about. If you have any questions, I can answer. Thank you.
I
Yeah?
So, are you going to? I am not good with process.
Oh, it's not on.
Neither am I. I am not good with process. So, so how much of this software, once we get this open source community going, are you going to be willing to release? Don't answer. We'll talk.
Yeah.
Are there any other questions? Yes.
The micro mock
Yes.
web, is that something you guys built for this project, or is that something that's already existing?
It was, I'm glad you asked. That was something already existing, but it didn't have this nice, beautiful GUI interface in front of it. They developed that GUI interface. The micromock previously was just like menu-driven, you know. It had a drop-down menu at the top and things like that.
Did that come with the UAV, or is it?
Pardon?
Did that come with the UAV?
No, this one didn't come with the UAV.
Oh,
No,
okay.
It didn't come with the UAV.
But where did it come from? Was it an APL product?
Yeah.
Okay.
So we have a very bright engineer who has been in APL for 40 years, and he uses this to build any kind of devices, device drivers and things like that. He really loves that. So somebody picked up on that and said, you know, let's put a GUI in front of it and see what happens.
And the other question is, it has a UDP interface over the Wi-Fi.
Yes.
Were you sending CCSDS packets over that interface?
I believe they hacked it, yes. They did that.
Okay, thanks.
Any other questions? Yes.
So the processor that comes with the AR drone, it's kind of similar to what the BeagleBone is. So I was wondering, why did you strap a Raspberry Pi to the drone?
He didn't win the drawing yet.
I don't know why, but maybe the two engineers who were going to burn that midnight oil, they were more used to Raspberry Pi then. That probably is the reason.
It's cheaper.
And
About $20 cheaper.
yeah.
Any others? Okay, very good. Thank you.
Okay, thank you very much.